Now that we know when a normal distribution can be used, let's look at the sampling distribution of the sample proportion. We'll learn its mean, its standard error, and how to calculate both using a simple example. Let's begin. Before we learn the formulas, let's review the notation. Lowercase p represents the population proportion. The symbol p hat represents the sample proportion. Mu of p hat is the mean of the sampling distribution. Sigma of p hat is the standard error, and n is the sample size. The first formula is the mean of the sampling distribution. Mu of p hat equals p. This is an important result. It tells us that the average of all possible sample proportions is equal to the population proportion. In other words, the center stays the same. The second formula is the standard error. Sigma of p hat equals the square root of p times 1 minus p over n. The standard error tells us how much the sample proportions tend to vary from one sample to another. Notice that the sample size n is in the denominator. As the sample size increases, the denominator becomes larger, so the standard error becomes smaller. That means larger samples produce more consistent sample proportions because they vary less from sample to sample. When the normal approximation conditions are satisfied, we can summarize the sampling distribution using this notation. This notation simply tells us that the sample proportion is approximately normally distributed with mean p and standard error of square root of p times 1 minus p over n. Let's work through example 3. Suppose the population proportion is 0.20 and the sample size is 507. We want to find the mean and the standard error of the sampling distribution. Round to 2 decimal places. Let's start with the mean. We are using this formula, mu of p hat equals p. And p is 0.20, so mu of p hat equals 0.20. Next, let's calculate the standard error. We are going to use the formula sigma of p hat equals the square root of p times 1 minus p over n. We will replace p with 0.20 and replace n with 507. 1 minus 0.20 is 0.80. So we have the square root of 0.20 times 0.80 over 507. 0.20 times 0.80 is 0.16. So we have the square root of 0.16 over 507. Now let's put this in our calculator and we'll get 0.0177646,237. And we need to round it to 2 decimal places. So we get 0.02. So our standard error is 0.02. So the sampling distribution has the mean of 0.20 and standard error of 0.02.